So this is 9.5, and it's about something called mean absolute deviation. Could I have a volunteer read our learning target where it says LT? Grayson? Thank you. So another measure of variation, yesterday we learned about two, range and interquartile range. And another one is the mean absolute deviation. The mean absolute deviation is an average of how much data values differ from the mean. That's why we hear the word mean and deviation. Deviation is like how different something is. So this is the mean or the average of how different our values are from the mean, how far away they are from the mean. So the steps to finding it. Step 1, find the actual mean of your data, meaning add them up, divide by how many there are. Step 2, you need to find the distance from the mean that each data value is. So once you have the mean, you're going to look at each of your values and say, how far away is this number from the mean that I just found? Step 3, you are going to add up all those distances. And step 4, divide by the number of values. So really what you're doing is finding the mean, finding how far away every number is from the mean, and then finding the mean of those numbers. So you're finding the mean twice here. So let's walk through it. Here's our data set. Step 1, find the mean. How do I do that again? Emma? So I'm going to add up all these numbers, divide by how many there are. So 1 plus 2 plus 2 plus 2 plus 4 plus 4 plus 4 plus 5. What would I want to divide by for this data set in finding the mean? Ratisha? Because there are 8 values. Remember, in your calculator, you got to put all the addition in parentheses or do the addition, press equals, and then do the division. That's going to give you 3. So our mean is 3. The average, a way to describe the average would be 3. Step 2. Now I'm going to find the distance that every value is from the mean. How far away every single value is from the mean. I'm going to write find distances from mean. If you don't want to write the words, that's probably fine because they're also up above in the steps. That's kind of up to you. So what I mean by that is our mean was 3, okay? So if I look at my first value is 1. How far away is 1 from 3? Logan? So that's my first distance, and that's again because the mean was 3, my value was 1. The difference between those is 2. That's how far away it is. My next value is a 2. So how far away is 2 from my mean of 3? Neil? It's just 1 away. And that's because my mean of 3, if I take away the value of 2, I get 1. Well, I have 2 more 2s, so I know I'm going to have a 1 2 more times because 2 is 1 away. We already figured that out. I don't need to redo it. I just need to write it down a couple other times. My next value is a 4. How far away is 4 from the mean? From our mean? Aubrey? 1 away because if our mean is 3, 4 is 1 away. So 1 again, and that's because if we subtract those, they have a difference of 1. And there's 4 2 more times. So I'm going to write down 1 2 more times. And then my last value is a 5. How far away is 5 from our mean? Sandra? 2. 2 away because 5 minus 3 is 2. When I'm writing that little subtraction thing, it's not because you necessarily need to type 5 minus 2 in your calculator. It's just reminding you how you could find the distance if you didn't know. With these numbers, it's pretty simple, right? Like how far apart are 2 and 3? That's pretty simple. But if you had a little bit more complicated of numbers and you're like, I don't know that off the top of my head, you could just subtract them to see how far apart they are. And then I'm going to combine steps 3 and 4 into 1 because I think it makes more sense to write it as 1. I'm going to find the mean of the distances. So I have a list of distances that I just wrote down. I wrote down how far away every value was from my mean, and I'm now going to find the mean of those values. which means, again, add and divide. So this time I'm adding 2 plus 1 plus 1 plus 1 plus what? There's a lot of ones here. How many are there? 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. And then a 2. What would I want to divide by this time? Yeah? Yep, because there are 8 values, which makes sense because if there were 8 values at the beginning and I was finding distances, how far away each one was from the mean, that means I ended up with 8 distances. When I do all of this, I get 1.25. So now we're going to talk about what is this telling us, because like everything in this chapter, unless we know what this is telling us, it's not really valuable to us. So our mean was 3. That means that on average, I don't know what this data is about. Like, I don't know what question they were asking people. Maybe they asked how many siblings people have, okay? Let's say that's what it was. According to the mean, most people on average have about 3 siblings. That's what our mean is telling us. When we find how far apart everything is and we find the mean of that, we are saying on average, people's number of siblings is only 1.25 away from the mean. So pretty close to the mean. I know there's not 0.25 siblings, but just to give you an idea of what it's saying, it's telling you about how far away your values tend to be from the mean. So it's telling you if your values are very close to the mean or if your values are very far away from the mean. When you have a data set where all the numbers, like they have a small range, it makes sense that this number would be small. If we have a data set where the values like have a huge range, like 0 to 100, chances are we're going to have a bigger mean absolute deviation because those numbers can be way far away from the mean. So I'm going to write data values are no more than 1.25 from the mean. On average. I should write on average. Because obviously some of our values are further than 1.25 away from the mean, right? I have some that are 2 away. But on average, most of them are about 1.25 away from the mean, meaning they're pretty darn close to the mean. That's not too far away. Questions about this example?